Hey everyone, and welcome to The Explainer. Today, we're diving into a massive, honestly monumental shift in human history, that incredible leap from physical wires to the very first generation of cellular networks, what we call 1G. You know, we take our seamless, everywhere-you-go mobile connectivity totally for granted today. But the journey to untether us from our desks and living room walls, that required a complete top-to-bottom reimagining of how telecommunications actually worked. I am so pumped to guide you through this technological breakthrough and unpack exactly how 1G networks changed communication forever.
Okay, let's dive right into this. It's a running theme in history that humanity vastly underestimates the explosive demand for new communication tech. When U.S. President Rutherford B. Hayes first saw Alexander Graham Bell's telephone back in 1876, he was impressed, sure, but ultimately kind of dismissive of its practical appeal. The idea that everyone would want their own phone? It just seemed absurd at the time. But obviously, the telephone became an indispensable tool that completely transformed global society. And as we'll see, that exact same underestimation happened all over again when we first tried to make those phones mobile.
To truly get the 1G revolution, we really need to understand what it replaced. For decades, the entire world was quite literally tethered by this massive physical wire infrastructure. While the telephone allowed instant communication over huge distances, it absolutely required a physical copper line connecting the caller, the switchboard, and the receiver. If you wanted to make a call, you were basically anchored to a specific spot. Cutting that cord, moving from those fixed copper wires to the total freedom of mobile radio waves, well, that was the ultimate engineering dream. But early attempts to pull this off, they ran headfirst into some massive physical roadblocks.
So here's our quick roadmap for the explainer today. We'll look at what came before the cell, then the cellular breakthrough, the first generation itself, the global analog rollout, the limits of analog, and we'll wrap up with the mobile foundation.
Starting right off with Part 1, Before the Cell, taking a look at 0G mobile networks. So before we had 1G, we actually had these early mobile radio telephones known as 0G. And get this, the number 3? That represents the absolute maximum number of simultaneous calls allowed on the entire metropolitan network in a place like St. Louis. Just 3! The original network there operated on barely 6 channels, which actually had to be bumped down to just 3 to stop them from interfering with each other. Literally, if a fourth person in the entire city wanted to make a call from their car, they couldn't. No way. They just had to wait.
And the reason for that unbelievable bottleneck all comes down to the architecture. Single G networks relied on a single, super high-powered transmitter to cover a whole city. Because radio spectrum is a strictly limited resource, regulatory bodies only handed out a very few channels. If you tried to cram more channels onto that one giant tower, they'd just trample all over each other and cause massive interference. As a result, early car phones were basically useless for the general public. Subscribers dealt with severely limited capacity and these agonizingly long wait times just to hear a dial tone. The basic physics of radio waves meant a single tower was never, ever going to scale up to handle a whole city's traffic. Which brings us to Part 2, the cellular breakthrough. Why engineers had to start thinking small to scale up.
Now, what's really interesting here is the architectural pivot that completely changed the game. Engineers at Bell Labs realized that if they wanted to support millions of users, they had to stop thinking big and start thinking small. So instead of one giant tower blasting a signal over a 50-mile radius, a cellular network divides a city into a sort of honeycomb of smaller geographic areas. They called these cells. And each cell gets its own base station with a low-power transmitter. Because the transmitters use low power, the radio signal actually doesn't travel very far. And surprisingly, that's a brilliant thing. It means the exact same frequency can be reused by another cell just a few miles away without causing any interference at all. This concept, frequency reuse, completely shattered the old capacity limits of 0G.
But of course, the cellular concept introduced a totally new, massive engineering headache. I mean, what happens when you're driving your car and you cross the border from one cell into another? The answer is this really clever thing called the handoff process. As your mobile station moves toward a cell boundary, the network is constantly keeping tabs on your signal strength. A centralized, computerized, automatic switching center called the MSC manages the whole shebang. When it detects your signal dropping in your current cell and picking up in the next one, it seamlessly transitions your call to a new frequency in that new cell. All this back-end magic happens in about 100 to 200 milliseconds. That's literally the blink of an eye, fast enough that your conversation doesn't drop.
Okay, moving to Part 3, the first generation, 1G. The real analog era begins here.
That brilliant cellular concept was finally commercialized and rolled out to the public as what we now call the first generation, or 1G. Now, 1G was an analog technology that relied on something called FDMA, frequency division multiple access. While the complex control signals talking back and forth to the cell towers were actually digital, the voice transmission itself was pure analog. Think of it kind of like an FM radio. FDMA basically meant that when you made a call, the network assigned a discrete, dedicated frequency channel entirely to you for the whole duration of your call. Nobody else could use that specific frequency in your cell while you were talking. You are hogging the whole lane.
And this brilliantly illustrates just what a dramatic leap forward this architectural pivot really was. We went from that awful 0G bottleneck, one high-power tower, minimal capacity, maybe 3 lucky people talking at once, straight to the 1G breakthrough. Suddenly, we have a grid of hexagonal cells, low-power transmitters, and this massive frequency reuse. By implementing this cellular architecture, networks could all of a sudden support not just tens of users, but thousands, and eventually millions, right within the same geographic area. It was a total game changer.
Let's look at Part 4, a global analog rollout as 1G spreads worldwide.
Once the cellular concept was proven to actually work in the real world, a frantic global race kicked off to build out the infrastructure. Back in 1979, NTT launched the very first commercial cellular network in Tokyo, Japan. Pretty soon after, in 1981, the Nordic countries launched the NMT standard. Over in the US, Ameritech fired up the first 1G network in 1983 using the AMP standard, which you probably know for its iconic brick-sized Motorola Dynatac phone. And by 1985, the UK had launched its TAX network, actually ringing in the new year with a famous call from Michael Harrison to his father, who just happened to be the chairman of Vodafone.
But honestly, the 1G rollout was a bit of an alphabet soup. The USA used AMPS, the Nordics used NMT, the UK used TAX, West Germany had C450, and France had Radiocom 2000. So while the core cellular tech was spreading globally, it was heavily fragmented by region. Because of these completely different standards, international roaming was virtually impossible, with the notable exception of the pioneering NMT system across the Nordics. But generally speaking, your American AMPS phone was basically a highly expensive paperweight on a French Radiocom network.
Even with all that fragmentation, 1G proved one thing loud and clear. There was a massive, pent-up public demand for mobile communication. Remember President Hayes wondering who would ever use a telephone? Well, early predictions for cell phone adoption were just as hilariously wrong. Subscriber bases rapidly exploded from a few thousand into the tens of millions worldwide. Look at the Motorola Dynatac, the first commercially available 1G phone in the US. That thing cost $4,000, weighed nearly a kilogram, and gave you a whopping 30 minutes of battery life. And yet, it became an absolute cultural icon of the 1980s. People just wanted to be connected, regardless of the cost or how clunky the tech was.
Which leads us to Part 5, the limits of analog and why 1G desperately had to evolve.
So, the crucial point is, while 1G was an incredibly important stepping stone, it was far from perfect. In fact, it had some fatal flaws. First off, because it was an analog FM signal, it was completely unencrypted, like totally open. Anyone with a basic, off-the-shelf radio scanner could literally tune in and eavesdrop on your private phone calls. Yikes. Second, it was voice only. No internet, zero data, no text messaging whatsoever. Third, that FDMA technology we talked about, it turned out to be a massive spectrum hog. Dedicating a full frequency to just one person for a whole call was highly inefficient, as the number of subscribers skyrocketed. Plus, analog transmission required a lot of power, meaning it just chewed through phone batteries incredibly fast. Let's move ahead just a bit and see how this builds into the next era. These fatal limitations of 1G analog basically forced the telecommunications industry to go back to the drawing board and invent 2G digital networks in the 1990s. 2G digitized those voice signals, which immediately allowed for encryption, finally stopping the eavesdropping problem cold. 2G also brought us SMS text messaging. And crucially, 2G used digital multiplexing technologies, things like TDMA and CDMA. This was huge, because it allowed multiple users to share the exact same frequency channel at the same time. It massively increased network capacity and solved that pesky FDMA spectrum hog issue once and for all.
Finally, Part 6, the mobile foundation. Let's look at the true legacy of the 1G era.
Ultimately, the true legacy of 1G isn't really the clunky analog technology itself. The real legacy is the architectural proof of concept. 1G proved, out there in the real world, that the cellular network design, dividing up geography into low-power cells with automated frequency handoffs, actually worked on a massive scale.
It essentially gave birth to what is now a trillion-dollar global industry. Without those heavy, wildly expensive analog brick phones of the 1980s, working out all the physical infrastructure bugs, the seamless digital smartphone revolution we rely on today, it simply wouldn't exist.
So, 1G successfully cut the cord. It proved we could talk while moving freely around a city. But it was limited to just voice. It leaves you wondering, what happens when the whole world doesn't just want to talk, but wants to text, browse the web, stream video, and connect absolutely everything all at once? That exact explosion of data demand is what drove the creation of 2G, 3G, and beyond. Thanks so much for joining me on this explainer, and keep questioning how the amazing technology all around you came to be.